right, good afternoon, everybody. Welcome to the StorTrends Virtual Lunch and Learn. My name is Tyler Newberry. I'll be your host and moderator for the Lunch and Learn today. With me today is one of our senior team members, Todd Shadoba, as well as Solutions Engineer George Rodriguez. Todd and George will be joining us in just a second, but first, while everyone's still kind of getting in and getting their pizza and everything, just want to go over a few housekeeping things first, and then we'll get started. So number one, if you're in a pizza delivery zone and requested a pizza during registration, that pizza should be arriving within the next few minutes if it hasn't already. Now, sometimes the delivery person does run a few minutes behind. If they are running late, we ask that you please be patient with us, but be sure to let me know if your pizza has not arrived by 1:15 Eastern Time. Email is the quickest way to let me know if your pizza has not arrived on time. My email is tylerin@ami.com and is listed in your chat screen on the presentation if you need to reach me. That last message just goes for folks who are in Eastern, Central, and Mountain Time. For our folks in California, West Coast, and Hawaii, your pizza will be arriving later, and you've already received us notification on that, so we are good there. Number two, please ask us questions during the presentation. We want to provide as much of an interactive experience for everyone as possible, so feel free to shoot your questions over via the Q&A communicator located at the bottom right-hand corner of your screen, and we will either answer your question live on air or we'll send you a message back on the communicator. And finally, if we do experience any technical difficulties today, such as losing audio or if the screen becomes grainy for a moment, just please bear with us while we address the issue. These things tend to resolve themselves within a few seconds. As you know, technical issues are rare, but can certainly still occur. But that's it for all the boring stuff. Let's go ahead and get started with the presentation on all-flash storage. So I'll go ahead and turn it over to Todd.
All right, thanks, Tyler. Certainly welcome everybody to the event. Look forward to getting through this guy. We should be able to complete this within the hour. Obviously, we don't want to take up too much of your time, but look forward to showing you a little bit about StorTrends, the different products that we've got in our product family. Obviously, talking about hybrid and all flash and some of the benefits that brings to the table. So let's go ahead and get started. So my name is Todd Shadoba. I am a senior sales executive for the channel team here at American Megatrends. I've actually been here for 24 years now. I work pretty much in the pre and post sales for the StorTrends team and the other channel divisions that we have. I've worn a number of hats here for American Megatrends, primarily in hardware engineering and RAID engineering in the past, and I've been with the storage team for about the last 8 or 9 years now. George Rodriguez is also with us. He's one of our sales and solutions engineers. He's also been with AMI a number of years and has a lot of experience in storage and RAID and BIOS and some of the other product divisions that we have as well. So. That being said, we'll kind of jump into the agenda. We're going to introduce you a little bit to who AMI is, who StorTrends is, how we came to be. From there, we'll jump into the understanding of what the storage landscape looks like today. We'll talk about the different architectures of the all-flash, hybrid, and spinning disk comparisons that we've got in our product family. Dig a little bit into the feature set and technology that we have, as well as our support, and then from there I'll hand it over to George, and he'll run us through a demo of the 2610. So that being said, let's go ahead and jump into the actual presentation. So for those of you that don't know, we are StorTrends is a product division from American Megatrends. American Megatrends was founded back in 1985. We are still held and operated by the founder, Subramanian Shankar. We were started here in Atlanta, Georgia. We do have a worldwide presence in America, Europe, as well as Asia. We do have 1,400 plus employees, and we basically have about 80% of those employees are focused on at an engineering role of some sort. So we really put a lot of emphasis on the actual development and engineering of our products. As you'll see when we step through the next couple of slides, we got a number of divisions that really, has a big footprint in the industry today, where we actually have a presence in over half the computers in the world today. So that's a pretty impressive thing to actually say. Over the 30-plus years that AMI has been in existence, we've obviously maintained a big focus on innovative IP. Throughout the company, we've got over 375 patents. We've got over 128 of those are just in the StorTrends storage by itself. So obviously, we've got billions of products shipped. Our mission statement is to provide our customers with the highest quality products the first time, every time. And let's talk about some of the different products that we have. So I'm sure a lot of you may or may not have heard of American Megatrends, or maybe you heard of it and you weren't 100%. You were like, I think I know who that is. Maybe this picture might help you out a little bit. Back in the old days, when you would watch your memory count up and whatnot, you would see this logo come up. So American Megatrends is that old BIOS company. We have been around since 1985. We have been and continue to be the number one BIOS provider in the world today. We obviously ship in millions of PCs every year. We have a presence in servers, storage arrays, desktops, thin clients, notebooks, laptops, etc. So that is still one of our, obviously that's what we founded this company on, and still is definitely a mainstay of who American Megatrends is today. Another one of our big product divisions is the remote management division called MegaRack. We developed this IP back in 1997. So this is basically remote access, remote KVM, IPMI. So we've got a lot of the brains that's under the hood of a lot of the products that are out there that are serving as your IPMI or your remote services to your servers and whatnot. This has been so if you're familiar at all with like the Dell D-Rack or some of the other big manufacturers out there, we're actually the brains behind a lot of their IPMI stuff that's out there. So dating back, we actually have a long history of storage as well. So the MegaRAID card back in 1994 was the largest or #1 selling RAID card on the market at the time. Gartner recognized us as the #1 vendor on the Magic Quadrant. But back at in the late 90s, early 2000s, technology was kind of moving down to silicone. We're not a silicone foundry. We're a software development house. After around 2001, as we sold that division off to LSI Logic, that product is still being sold and is still a leader in the RAID industry. They're known as Avago right now. So that's our beginning into storage. So obviously, after the sale of the MegaRack division, we had to take a hiatus out of the storage industry for a little while, as you can much understand. But after our non-compete had expired, we pretty much brought the core development team from that RAID development core development team back to begin writing the code for StorTrends. So StorTrends is ours. It is our product from the ground up. We're not just another ZFS-based type product that we slapped a bezel on a chassis and called ourselves a storage team. This is actually our product that we've written. In the early days, around 2004, when we started writing the code, we kind of went out as more of an OEM type of a product. We had a number of very successful launches with a number of different vendors that are out there. After the years went by, as we all know, there was a number of storage acquisitions that occurred over the years. So really over about the last 5 or 6 years or so, we've really focused more on the channel and bringing the product out to the actual end customers as opposed to just staying under the hood. So looking at what the product family looks like today, here's just a quick landscape of what we've got. So we still have all spinning arrays, the 3400, which has been out for about 6 or 7 years now. We also have our hybrid array, which has been out for a few years, where we introduced some SSDs into the picture. And then over the last couple of years, as SSD prices have come down, We certainly implemented those into our product family. So we've got a couple of, we are in our second phase of our all-flash offerings. So a lot of people ask, well, where do you guys typically fit in the industry? Well, the simple answer to that is, we pretty much fit everywhere. Obviously, there's pretty much every vertical that's out there is going to be dependent upon the, the storage or the data that they've got. Everybody has to store that data, so therefore we really lend ourselves well to pretty much all the verticals that are out there. As far as where we typically target our customers, we typically find them in the education, finance, healthcare, manufacturing, legal, retail, service providers, small enterprises, and of course government and the public sector as well. Here's just a quick snapshot of just a few of our customers that we've got in the field today. Through the years, we've got thousands of installs around the world of StorTrends. So, like we pointed out on the previous screen, this is going to be, pretty much a landscape of all the different verticals that we're going to find ourselves in. So I kind of want to step into why it is that we're actually here. There's a number of drivers that bring people to events like this. So here's just a few of the ones that we kind of run into. Today, latency is certainly, as we get into the all-flash and whatnot, performance is obviously key. When it comes to SSDs, though, IOPS is not necessarily the limiting factor as it was when we were talking about all spinning disks and whatnot. So high latency becomes a really, that's really the measure of where your performance is actually going to be. So when people are experiencing a lot of high latency and whatnot, that's when they start looking into, how am I going to get my users, up to speed and keeping them happy, keeping my applications from timing out, et cetera. Excuse me. VDI, that's certainly a hot topic these days. A lot of folks are, if you're not already implementing it, there's usually been some discussion as to whether or not VDI actually fits for you. Certainly our storage arrays fit into a VDI environment pretty easily. At the end of this, I'm going to touch on another product that we've got that we can dig into probably at another day, but at least I want to let you be aware that it's out there. Obviously, some of the standard reasons for going to an event like this, you're running on some older storage. We certainly run into customers that are, band-aiding their 6- and 7- and 8-year-old storage arrays. So obviously, sometimes it's time to, start looking at something newer that's going to be a little bit more dependable. Running out of capacity is certainly a typical situation. You might have a new business division or something that you have a whole new project that you're scoping out for. So that brings a lot of people in. Certainly learning and planning. I know that there's a lot of folks out there that want to know what's out there in the industry and keep tabs on how things are moving. The last one's a fun one I like to put in here. We do these events pretty frequently, and I was doing a live event at a restaurant about a year ago or so, and as I was shaking hands, people leaving and whatnot, I usually ask what people are working on or if there's something I can help out with. And the guy just said, look, Todd, you guys were offering a free lunch, so I decided to show up. So if you're here for the free pizza, enjoy the pizza. I hope you get a little bit of good information here, and maybe we can plan on some stuff in the future. So what I'd like to do now is kind of jump into the landscape of what we have as far as the different types of SAN arrays that we've got out there. So these are basically comparing what we've got, but a lot of these are going to compare similarly to what some of the other vendors actually offer. So the 3400 is our all-flash, is our all-spinning array. This is going to be full of either 15,000 RPM drives, or it's going to have the 7200 RPM NL SAS drives. Obviously, we can mix and match different RAID types, different disk types, and of course we can carve this up to have different performance being delivered to different data sets. When we brought this out, this introduced a lot of our tiering technology, which is important because a lot of that same technology actually carries forward into the hybrid and even the all-flash array, and of course we'll dig into those as well. The 3500, which has been out for a few years now, is our hybrid array. What our hybrid is going to be bringing in SSDs as well as spinning drives as well. We're a little bit different than some of the other guys in the industry. We actually bring a caching layer as well as a tier layer of SSD, and then of course we backfill the rest of the array with spinning drives. What we're doing there is we've got a lot of volume pinning and a lot of technology that's built in there to make sure that we're providing the performance to the performance-needed applications when needed. So what I mean by that is if you've got some critical databases that you know that you have to have the performance there, we'll actually pin those and make sure that the priority of those volumes are going to be served by the SSDs. On the flip side of that, you might have old cold tier or old cold data that's actually not being accessed very often. So basically what we're going to be doing is looking at the blocks. We're going to be seeing what's being accessed most frequently. When blocks get less accessed less frequently, we're going to go ahead and demote those guys down to the cold tier, and that way we're going to relieve the space on the performance tier for the newer incoming I/O. The 2610, this is our all-flash, our latest all-flash array that we've got. This is, of course, going to provide all-flash for all levels of your data. And, of course, we're going to be able to deliver a much more consistent performance throughout this entire array. I'm going to hold off on explaining kind of the architecture and the flow of the I/O until we get into some of the slides here coming up. Here, again, is just some of the different product models and the breakdown of what they are. 3400, 3500, 3600, those are all 3U 16-bay chassis. And of course the differences are going to be, the different drives that are being utilized, the different CPUs and memory that are going to be utilized for each of those. This is a bit of an eye chart, so I'm not going to go through all of these. But one of the things to point out really at this point is that we've got, of course, a bunch of different features that are built into the product. One of which is going to be replication, and a nice thing that we bring to the table is that we can actually replicate between the different boxes within the product family. So you can have that high-performance all-flash array at your primary location, but you don't necessarily need to have that same capital investment at your DR location. So you could maybe put a 3400 out there. So definitely a nice feature to have. So one of the reasons that we're talking about all flash, and of course some of the advantages of all flash is pointed out in this chart. And basically what this is the same type of workload that's being injected into each of our different products that we have. And what this is a chart showing the actual average latency during this run. So the red line that you see on top, this is going to represent, this doesn't represent, this is the actual output from a 3400 all-spinning disk array. And what you're seeing is pretty high latencies going on here. When you start getting above, that 20 and 25 millisecond rate, that's when you start seeing, your VMware start, not liking that amount of latency. You might start seeing disconnects and whatnot. So obviously these latencies become a problem for your environment. When you're talking about tiering and whatnot, you see the peaks and valleys that are going on there. This might be when you're writing to that hot tier and then you start taking some read from your cold tier or something like that. That's where you're starting to see the latencies kind of, bounce up and down. Moving down to the green, now you see this is going to be it's a lot better obviously than the all spinning array, but you still see some of those peaks and valleys as you're filling up your performance tier, or you're taking writes off of your or reads off of your back end tier. The latency here is not as bad, but again, you're still seeing some inconsistencies as far as where you're going to get your performance. The bottom line, of course, is the all-flash array. This is where you're going to get, consistent performance throughout, and the difference between reading from write and read tiers, of course, is not going to be as significant since all of your I/O is coming off of the very high performance, flash disk. So one of the things that we definitely like to make sure everybody knows is that our price points and whatnot, we are very aggressively priced. You're going to find that, certainly compared to some of our competitors out there, we're able to provide a really, really advantageous price point for getting into the all-flash market. We've got a price quote generator tool that's found on our website. You can definitely go there and fill in some of your application needs, some of your desires, your capacity, et cetera. And we, of course, can generate a quick report for you as far as what our price point comes in at. This here is kind of where the rubber hits the road. This is an important slide to kind of really point out, how these different arrays come in at the different price points that they are. So, of course, on the left we have the 3400, and what we've tried to do is get as close as we can as far as a capacity or usable capacity for each of the different arrays that we've got. So on the far left is our 3400, starting out with 73 terabytes of raw capacity. After rating and everything out, we end up with about 58 terabytes. The 3500, again, we're starting with about 73 terabytes. After this one's all rated out and, the hot spares added and this and that, we're at about 50 terabytes. An odd thing happens over here on the 2610. We actually start out with 28 terabytes, but we have a usable capacity of, 52 terabytes. We'll get into why that is here in just a minute, but I kind of want to just go through some of the rest of this stuff. Obviously, when you're talking about, all spinning drives, you're talking about a lot more power. You're talking about a lot higher latency, a lot lower IOPS and performance. From a rack space perspective, it's not that much different, but of course your yearly power consumption and your CO2 emissions are very high compared to what the all-flash and hybrid array brings to the table. That being said and done, looking at the street price of the hardware that we're talking about here, you're looking at about a little bit less than 50 cents per gig. That's not too bad considering that amount of capacity. Moving on to the hybrid array, obviously we're bringing in the SSDs now, so you're seeing the latencies really drop. You're seeing the IOPS really go up. The power consumption dropping a pretty considerable amount, and we're really losing a lot of the CO2 emissions. Obviously, you expect to pay a little bit more for having that additional performance, but we're looking at having about 63 cents, per gig here. Now, moving on to the 2610, like I said, it's kind of an interesting anomaly how we went from 28 terabytes up to 52 terabytes. And obviously, one of the things that we're bringing to the table is the dedupe and compression ratio. So generally what we're seeing, and what we have in this example, is where we're seeing about a 3.3 to 1 data compaction ratio. So that's why that 28 terabytes is actually going to be seen as 52 usable terabytes. And obviously that dedupe ratio is going to be key in making sure that the price point is actually going to, reflect what it is that we're hitting here. So obviously from a performance perspective, we're talking about a less than a millisecond latency that's going to be very consistent across the board. We're hitting IOPS of in the neighborhood of 250,000 IOPS. This is a 2U 24-bay chassis. Obviously, the yearly power is going to be down almost by half of what the all-spinning drives was, and of course the emissions are going to be much lower as well. Again, looking at this type of a dedupe ratio and looking at this particular configuration, this actually matches where the hybrid array is. So in some slides coming up, we'll kind of get into, where each one of these is going to fit a little bit different and whatnot. So that way, when you're making a decision on your storage projects, you'll know which direction to go in. All right, with that being said, I'd like to jump into some of the feature sets that we've got here. Specifically to the 2610. We do have dedupe and compression, where it's obviously going to give us a lot of the space savings, which is really going to get your dollar per gig down to where you want it to be. The read and write optimized tiers, as well as the in-left cache and whatnot, which we'll get into some of the details of that in the next couple slides. What I'd like to really touch on here on this particular slide is that this isn't just a box of disks that's got nothing but performance, needs here. This is a full-fledged SAN. We've got, all the snapshots. We've got replication. We've got a lot of technology built around replication, where we've got WAN-optimized tools that are built in there to make your replication the most effective as it can be. Of course, all the auto data tiering, et cetera. Another thing that we'd like to point out here is that, we actually offer hundreds of different configurations to match the actual the performance needs as well as your capacity needs. We're not going to paint you in a corner where you only have 2 or 3 to choose from, and hopefully this is going to fit your needs. We actually can fine-tune the configuration to match exactly what it is that you guys are looking for. Obviously, with this, we're going to see the latency reduction. We're going to see the value with the data compaction, and then, of course, we're going to really lend ourselves well and with the 2610 to high-performance databases, mixed workloads, virtual environments, and VDI as well.
Todd, if you don't mind, we got a great question come in just a second ago, so we'd just like to ask it real quick while we're on the topic. So Charles just asked, what type of workload is the dedupe ratio based on? So I think this slide might touch on it a little bit, where we're talking about 4-to-1 data compaction ratio. It's just like, what kind of is that typical for all workloads? And if not, what kind of workload would you imagine seeing that on?
Well, the 3.3 to 1 is very typical from what we're finding from our standard customer. This is a really good question because that actually plays into what we're going to touch on over the next couple slides here. Not all workloads lend itself very well to data compaction and deduplication. That's exactly right. Generally speaking, we see a lot of mixed workloads, virtual environments, and even to some, there might be some VDI or terminal services or something like that that's being serviced on the array that we have. So in those types of environments where we've got, the database to work mixed workloads and the virtual environments, that's really where we're going to see, that typical 3.3 to 1, somewhere around there. I've got a customer that I was just working with the other day. They've got a heavy VDI load that's on there, and they're seeing upwards of 6 and 7 to 1 on their dedupe ratio. But yes, there are different workloads that aren't going to lend itself as well to the data compaction and the dedupe, which of course feeds us right into our dedupe slide here. So, of course, dedupe and compression, I'm sure most of us are aware, but for those of us that aren't, basically what deduplication is going to do is going to replace, a multitude of a same block that's written over and over again to having one block that's got all of the other instances basically pointing back to that one block. I like to use, for example, if I send an email to 10 people, instead of the server actually keeping 10 copies of that same email, it would actually only keep 1 copy of that. Then everybody else, anytime they wanted to touch that email, they would essentially be pointed back to that one instance. In this example that we're giving here, for example, say we've got a 4-to-1 data compaction ratio, and that's going to include dedupe as well as compression. If you had a need for actually 40 terabytes of stored capacity, you could actually get by with actually only purchasing 10 terabytes of actual SSD capacity. So that's obviously where a huge space savings comes in. This is obviously going to give us, in an actual read-write ratio of 70 to 30, which is a very typical read-write ratio, you're going to see 120,000 IOPS coming out of this at less than 1 millisecond of latency. So this is one of the things that we're doing that's a little bit different is how the I/O is actually being fed and where we're actually introducing the dedupe and compression ratio. This is also where our in-lift cache is going to come into play. So what I want to do is kind of get into a little bit about how the blocks feed through our system. So one of the things that we had done in our previous version of the all-flash array was we actually were doing all inline dedupe and compression as all I/O was coming into the box. One of the things that we saw, and of course we knew it going in, but there's always, anytime you're doing all of these mapping of all of these blocks, this, that, and the other, there's of course going to be a lot of performance hit to the actual I/O. Now, not everybody needs 100,000 IOPS in their environment, so that works pretty well in most situations. But one of the things we've run into is some folks that did have those higher IOP needs really didn't necessarily want to see that overhead in the way. So what we've done is we've kind of split up between a hot tier and a cold tier, and what the difference is on the 2U24-bay system, we're dedicating 8 of those drives to what we call a hot tier. We've got 2 drives that are going to be dedicated to our in-lift cache, then we have 14 additional drives that are going to be dedicated to our cold or archive tier. So when new I/O comes in, it's going to hit that hot tier. We're actually not providing any dedupe or any compression on that hot tier. So that way we're making sure that we're able to deliver the highest performance humanly possible for that hot data. Of course, as data becomes older, it's not being accessed as much. Of course, we're going to start demoting that down. So as they're not accessed, we'll go down to what we're calling the archive tier or the cold tier, and this is where we're actually going to go through our dedupe and compression ratio. So what we're doing is we're actually going to realize the best capacity savings that we can on the SSDs while still delivering the highest performance possible for your hot tier. In-lift cache comes in when, as we all know, even when you've got archived data, that data needs to be accessed from time to time. So obviously we're going to have a little bit of overhead when it comes to, going through the dedupe layer, but it's still SSDs. I mean, you're still going to have a tremendous amount of performance there. What we're also doing is trying to keep up with the endurance of these drives as well. So basically, if you do a rewrite to an existing block that's on that archive tier, it's actually going to be done on those 2 in-lift cache disks that we've got in the array. What we're going to do is we're going to maintain those blocks there till we see if this block is going to continue to be hit, and if so, we're going to go ahead and promote it up to the hot tier. So that way, we're going to be continuously giving all the performance possible. If that block was really just hit a couple times, we can go ahead and then commit all of those rewrites or changes to those blocks down to that archive tier, and that way, again, we're going to get the most out of the performance of the box. We're going to get the highest capacity savings through the dedupe and compression, as well as maintaining the endurance of the drives that are here as well. Obviously, endurance is going to be huge on SSDs. The more writes that you commit to these drives, then obviously the more at risk you're putting these. We've got a number of tools, and obviously in-lift cache is a big one of those that's going to ensure that we're keeping the wear and tear on those drives down. And in fact, we actually give a 5-year endurance guarantee as long as you're under a service contract with us, to where we're going to replace any drive that runs into any endurance problems at all. So, of course, this leads back to the question that just came in a few minutes ago, is how do I know what the best option for me is when we're talking about these different things? They all have their advantages and disadvantages from time to time, especially when you're talking about juggling between, an all-flash or a hybrid array. And the point that was made, during that question is, of course, exactly one of the big reasons where you're going to make your decision between hybrid and all-flash. So you got that, a lot of virtualization and mixed workloads and databases and stuff like that lends itself well to, dedupe and compression. That's typically where you're going to find that your all-flash array is really going to be the best bang for your buck. Hybrid, of course, is going to be good in a scenario where you might have a small amount of your data that is really hot, but you've also got a large amount where you've got a big capacity need that's really just cold data that you just need stored somewhere, is really going to be the best position where your hybrid is going to fit as well. So, of course, one of the things that we want to know is, well, how do I know? What's my hot data? Can I afford that much hot tier? Can I get away with a hybrid array? We don't like to guess at what our configurations are going to be. We take a very hands-on approach when it comes to scoping out our configurations, and one of the tools that we rely on a lot is this tool that we call iData. This is a homegrown tool that we've built, and what this is an environment analysis tool. It's on our website. It's free to download. It's free to run. Basically, you would download it, you would run it on your vCenter. It would essentially go out and it's going to monitor all of the VMs that are in your environment. This is non-intrusive. All it's doing is collecting some of the metrics that your VMware environment is already collecting. And generally, it's going to run for about 7 days. And what it's going to do is give us a good capacity usage of where you are today. It's going to give us, what are your IOPS that you're actually pushing right now? a very important one when it comes to scoping out what your configuration needs to be, is what's your read versus write ratios. Obviously, what's your network bandwidth, your CPU and memory utilization, all of these things are all going to be, monitored from the tool. So this is a really good place for us to get a good understanding of where your environment is. It's also a good report for you to have on hand if you're ever trying to make a case to your management as to why it is that, hey, look at this bottleneck I've got here. This is something I need to address. It's a really good tool to run. Again, it's very simple to install. It's free to download, free to run. At the end of the 7 days, essentially, it'll generate a file. You guys would then email us the file, we would generate the report, give it back to you, and we could schedule some engineering time to actually go through and review the report with you so that you're in complete understanding of what all the report is saying, and obviously explain to us if there was maybe some anomalies that may not be a normal existence in your infrastructure. Anyways, I would highly encourage that you take a look at the iData tool. It's a really good place to get started. Support, this is an area that is, that AMI holds, at a very, very high regard. If you ever talk to any of our reference customers, this is, you're going to see some very glowing terms that people use for our support team. One of the first things to bring up here is we are headquartered in Atlanta, Georgia. It's not just, a business activity center. This is actually where the core development team sits for the StorTrends product. This is also where our entire support team is centered as well. So when you call into our support team, you're actually calling to our headquarters. We don't have any call centers that are set up halfway around the world where there might be language barriers or time constraints or anything like that. When you call, you're actually calling here. You're talking to one of our engineers. These aren't help desk technicians. These are folks with engineering degrees that are answering the phones the first time. We do have, next business day on-site support. All of our maintenance as far as firmware upgrades are going to be, can be done with no downtime. Of course, all of the hardware that we're utilizing we have dual controller, everything. We've got, power supplies are completely redundant and hot swappable. Of course, all the drives are going to be rated and this, that, and the other. So basically, all the hardware is going to be hot swappable and easy to do without bringing the box down. We provide proactive healthcare monitoring. This is not an additional fee to our standard support contracts. Basically, what we would do is allow our support team to be the recipient of your email address or your email alerts or any alerts that's coming from your units. So if we see, something coming in that requires some attention, you can rest assured that there's another set of eyes that are on your machine, 24/7. So if, you're at home having dinner with your family on Saturday night, if something goes on, you'll still know that somebody else is watching the box, even if you're not. Again, back to the endurance of the SSDs. As long as you're under a service contract, we do guarantee that those SSD drives will match the endurance for 5 years, and of course we will replace them with no questions asked and no cost to you in those 5 years. Of course, our support terms do range from 1 to 5 years. So again, support is certainly one of our we hold in high regard. You wouldn't be in business in the IT world for 30-plus years like we have if you didn't have a keen eye on how you're supplying your support. One last thing I want to touch on, then I'll stop babbling and I'll let George take over and show you the goods with the UI. One of our other channel products that we have is called Snap VDI. What Snap VDI is essentially a VDI in a box. So basically, this would be an appliance that you could roll in, and it's going to have all of the servers, all of the storage. We're going to do end-to-end. We're going to have everything all the way out to the 0 clients. We're going to make sure that you've got all the licenses that you need. So you basically have a VDI infrastructure that you got with one throat to choke. This is really awesome technology. I would certainly encourage you to take a look. If you're scoping some VDI, certainly let us know. We would like to at least discuss with you what we bring to the table and how we could be an advantage for you guys. That being said, I'm going to go ahead and turn this over to George and let you show you the good stuff.
Yeah, thanks, Todd. Hey guys, I hope you've enjoyed the presentation so far, and hopefully I can finish off here on a good note. So, let me get this up and running here. So you should be able to see the login screen that I have here open. And so I'm going to walk you through basically the main points of the UI, briefly touching on a couple of extra things here. So let's go ahead and log in. And while it's coming up really quickly, it's the the UI is web-based. So you can open up your favorite web browser, put in one of the IPs that's set up on the, it keeps coming up here. Yeah, I'm not sure what all that is. But
George seems to have superimposed some college logos and a soccer ball onto the UI here, so just pardon us while we get that taken care of.
Yeah. But so while I look at that, it's really odd. But yeah, like I was saying, we'll work with it, right? Yeah, you can open up your favorite web browser, put in one of the IPs on the system, and off you go with the UI. Once you do log in, you won't get all these extra little things that I got here on my screen, but you will get in the middle here, the very first thing that pops up is the data reduction ratio. You can see here, I currently have a 9.5. I'll go ahead, I'll be honest with you, I'm running a bunch of VDI and all that sort of stuff. So of course, mine is currently going to be higher than what the average that Todd was touting, somewhere between a 3 to 4 to 1 ratio. And so that kind of lends itself to, like he was talking about, if you are strong on the VDI environment, you are going to get a much better dedupe rate than somebody who's, doing a bunch of video files or, user files, things like that. But, for a normal mixed environment, somewhere between 3 to 4 is what you should expect. But how we read this here anyways, it's broken down into two halves, the top half and the bottom half. The top half here is the what I like to call the virtual space. And it's the space that you would physically need to have if you did not have deep and compression. This is the space that your servers will be utilizing as well. Excuse me. And so here in the middle, you can see here I have about 4.5 terabytes of utilized space. And then with the deep and compression there, you can see this correlation down to the bottom where I've only actually had to write down for 490 gigs or so. And so obviously the bottom half of this chart is for the physical space on the unit itself. To the left of those numbers there, you can see physically I have about 4.5 terabytes of overall usable capacity. So really, if I didn't have the dedupe and compression, I'd be right just about out of capacity there. But going on right above it, correlating back again with my current dedupe rate, I should be able to get about 43 terabytes out of this system here. To the right of it, you can see just how much is free, excuse me, for physical and the predicted capacity there. But that's just really quickly how you can see all of that. In the next section here, we have two main parts here. We have an events part and we have a smart part. For the events, basically anything warning, anything critical, anything that actually needs your attention will populate here automatically, so you don't have to go dig through it in the event log and try to see what happened when and all of that. So you can see here I have, excuse me, some access that dropped on a couple of my volumes. I actually did that myself. And then you can see, I'm trying to find it. I did it a couple days ago. I came in, and you can see the red ones for the critical alerts. Logically, I failed the drive, so you can kind of see hey, you know, something as critical as that will populate here automatically as well. So just a couple of things that I did there. But, you know, that's pretty much it. And, of course, anything that populates here, our support team would be the recipient of as well if the email alerts were configured. To the right of it, the smart status, we keep track of the smart health of each one of the drives as well as the temperature of the unit as a whole. For the smart, you know, these are all SSDs, so we're not looking at the traditional, you know, non-medium errors, the grown defects, things like that. We do keep an eye on them, but really all we're worried about with the SSDs is just the endurance levels. And the only thing that's really going to, you know, cut down on the endurance levels of the drives are the writes that go down to these SSDs. You know, you give power to the drive, you can theoretically read from it forever. So, having said that, as the number of writes pile up on the drives here, if the endurance levels drop under 20% for any particular drive, we'll flag it here. We'll send a replacement drive out to you so you can replace it on your time. From our internal testing, we've noticed that once it reaches 20% of endurance remaining, it kind of goes down exponentially from there, and obviously we don't want to be any cause for concern there within the environment itself. Our drives are rated for at a minimum of about 5 drive writes per day. And so what that means is, for example, if I had 200 gig drive, I could write 5 times that, so I could write a terabyte every day to that drive for 5 years, and it should be able to withstand all of that from the warranty perspective. So the next section here is our performance section. Excuse me. And so you can see we show latency, IOPS throughput. In here you can see the instantaneous values as well as the last hourly value here on the right. We do break it down between reads and writes as well. And on the left side, the charts, you can hover over any one of the charts, see on a particular point, you know, what the particular value was for, you know, for example, here the read IOPS, the read latency, the write latency, things like that. So you can kind of keep a good eye on how the performance of the system is going on at any given time, and this updates every 5 seconds. So, you know, you always have the last 2 hours in this window, and you have the hourly average here, as well as the instantaneous value up to the last 5 seconds here. So, down in the bottom section of this, we have I/O distribution, and we have read-write ratio. You know, the read-write ratio is very, excuse me, it's very informative. It's just telling you, hey, here's your read-write ratio. Whereas the I/O size distribution kind of gives you an idea of the block sizes coming in and going out of the system. The main importance for that is if you have lower block sizes, they're going to be more random in nature, whereas you have higher block sizes, they're going to be sequential in nature. And, you know, that kind of gives you a hint as to, you know, ensuring that either, one, the bandwidth is proper, or the IOP requirement is proper within the system. So going back up to the top here, we have another tab for the volumes themselves. And so in the first little part here, we have a table that has all of our volumes. And you can see the particular information for that particular volume, whether it's capacity information, whether it's performance information, what have you. I'm actually going to, there's one that I'm running stuff to. Where did it go? I don't see it anymore, of course. So, but anyways, if you go through this table, and, oh, there it is, right there at the top. And you click on another volume, like so, you'll see that it will actually have these charts similar to what we saw in the overall for that particular volume. And as you continue clicking through the table, you can see for a particular volume how it is performing in particular. But aside from that, you know, it's basically the same information. It's just on a per volume basis. So where I want to go to next is the hardware health, if it'll come up here. Actually, let me try to refresh this real quick, see if some of this stuff will go away. But where I'm going here is for the hardware health, and what this will do is it'll do a couple things. It'll have a physical representation of the unit, as you can see there. as well as anything physically about the unit that you might be curious about, whether it's the CPU utilization, whether it's the status of the individual physical components, whether it's how the individual NICs are being utilized, things like that. Well, of course it didn't work, so we'll go back to the hardware health here, bring it back up, and you'll be able to see that. And I'll show you here in a minute where you can hover over the individual physical components so you can get a little more information about those. But you can see here, here's the drive that I failed. Physically, you can see it's faulty there. And then you can also see there are blue I'm trying to say, bars here on the individual drives themselves. So it just kind of shows you the individual I/O load on a particular drive, making sure that it's evenly spread out between the tiers there. The yellow stars represent the hot tier, whereas the green stars represent the cold tier. And then the tags just basically mean that they're part of a storage pool, which is just a collection of the arrays there. You can see we have the information for the left and the right controller, CPU memory utilization, and network utilization as well. The reason that the left controller is higher is simply because we are in an active passive configuration by default, and so only the one controller is being utilized at any given point there. If we turn this over to the back, you can see a couple things. You can see this, the information on the components on the back of the system. So the power supplies, a couple fans, the NIC interfaces, things like that. I pulled a power supply, so you can see how that looks like when it's failed. But for the interfaces themselves, you can hover over them. It gives you a couple quick points of information here, IP, speed, status, things like that. So. But that's really quickly for the hardware health. Basically, like I said, it just gives you a physical representation and information on the physical components there. Another thing that I like to touch on during this is our wizards. So aside from just coming into the UI to manage the system, to check up on the system, make sure all the physical components are good, make sure the performance is good, you'll be creating volumes so that you can actually present them out to your servers. And so rather than making that very convoluted, I hit storage wizard. That's fine. Let's go to volume wizard. Rather than making it very convoluted in how we're trying to create a volume, we actually try to make it as easy as possible. So we have this wizard for it. And so all you got to do, give it a name. I'll do test vol. I got a bunch of test vols, 9, 8, I don't know. And so you give it a name, you give it a size. I'll do 4 terabytes for this guy. And then the target and everything else will be automatically created for you. One extra little thing, if you are presenting this particular volume to a cluster, allow multiple initiators there. Add to list, and then you can go through that as many times as you need for as many volumes as you want to create at any given point. Once you are done, you simply hit finish. Everything starts being created for you in the background. And we'll see here in a minute where there's an extra little pop-up that comes up that has your recommendations from us. And so one recommendation is for migration mode. And what that does is during a initial migration of data onto our system, we recommend everything go down to the cold tier. That way, the hot tier is not filled with otherwise cold data or unaccessed data. And so the reason for that is while we do have automatic tiering, promotion, demotion going on between the tiers, demotion is a lot slower than promotion is, and so it's a lot easier to promote everything up into the hot tier that needs to be there than it is to demote down from the hot tier down into the cold tier. Also, everything being sequential during a migration, we're not worried so much on the performance of it. We just need to have the bandwidth available for that, so it kind of evens out there. So the other thing, though, is for our timeout recommendations. It doesn't matter what hypervisor you use, what kind of OS you're using for a particular server. We have the timeout settings and how to set them to our recommendations. What that allows us to do is, ensure that we're not going to have any timeouts, anything like that could cause any sort of interruption within your environment. should refresh here on the side. And more or less, that's just very simple, a very quick overview of what the UI has to offer. Obviously, we have a lot more to offer within the UI itself, and but yeah, so real quick on that.
Awesome. Well, thanks so much, George. We've only got about 5 minutes left here, and we'll try to get you guys out at least with a little bit of time to spare. Just want to go over a few quick questions that we had just for the Q&A section right here. So we'll just knock these out real quick and let everybody go. We really appreciate everyone taking an hour of their afternoon to spend with us. We really appreciate you guys taking a look at us. And if you have any follow-up questions after the event, you can feel free to follow up with me at tylern@ami.com or visit us on StorTrends.com. and we'd be happy to help you out in any way that we can. First question, I guess we'll have Todd answer this one for us if he can. Does StorTrends offer any sort of try before you buy option for your sands?
Yeah, absolutely we do. That's actually a great question. Like I stated in the presentation, we definitely like to take a very hands-on approach as far as scoping out projects. Obviously, iData was a good tool there to begin that process, but we certainly recognize that I can promise you the sun and the moon all day long, but really the rubber meets the road when you can actually put the box on in your environment, beat it up on your terms with your I/O, and obviously verify, that what it is that we say that this is going to do will absolutely do. We do this as there's no obligation to do so. There's no conditional POs or anything like this. So, if you've got a project that you're scoping and you're doing some comparisons with some other folks, or you're just wanting to, make sure that this is the right fit for you, we would certainly encourage you to reach out to us, and we can certainly get you set up on a proof of concept.
All right, next question, I think fairly simple, but and we probably touched on it a little bit during the presentation, but we can go over it in a little better detail. Are you integrated with VMware, and please explain?
Oh, that's a really good question. Obviously, being in the storage world, if you're not working with VMware, then obviously you're kind of being left behind somewhere. But no, we've had a working relationship with VMware since I think 3.5 is when we really started, when we were integrating with them to begin with. But obviously, as far as plugins go, to manage the unit straight from your vCenter, we have support for that. All the VAAI primitives that are out there are certainly we certainly work well with those as well to ensure that you're able to get the most out of your virtualized environment.
Awesome. Just clicking right along here. How do I know, or how can I know if I need hybrid or all-flash storage?
That's a good question as well. Like we pointed out in the slide deck there, it really depends on, what your data set is, and if you're going to get the most out of, if you've got a data set that's going to lend itself well to data compaction and whatnot, then that's obviously going to be a good place to implement an all-flash. And obviously, if you've got a very known high-performance need and you've got, a much larger cold area that doesn't really require any performance at all, might be a good fit for a hybrid. So again, I would certainly encourage you to take a look at the iData tool. Again, free to download, free to run, gives us a really good perspective as to what would be a good fit for your environment.
Awesome. Just about enough time for 2 more questions here. What is the lifespan of the SSDs, and how long do you warranty them for?
Excellent. Yeah, we do the drives that we're using, the SSD drives that we're using, do carry a 5 drive write per day warranty on them, like George pointed out. Obviously, with that, as well as all of the tools that we've got built in, as far as in-lift cache, this, that, and the other, we are guaranteeing 5 years of continuous usage of these drives without failure. So 5 years would be the answer there.
All right, and last one, and then we'll let everyone go. How many IOPS in total can the 2610i all-flash handle?
That would be about 250,000 IOPS is what that's going to be.
Okay, perfect. Well, again, thanks so much, everybody, for your participation today. After you exit out of the WebEx, you should be redirected to our website. Feel free to just poke around there, explore, look at things that you might want to take a look at. If you have any questions on any of that information, there should be some contact us information in there as well. But feel free to reach out anytime, and if you have any interest in the iData tool and would like to get that installed, we can help with that as well. But for myself, Todd and George, thank you again for spending a little bit of time today with us, and we look forward to helping you with your storage needs in the future. Thank you so much.
Thank you.